Hi everyone, my name is Anjali Telang. I am a product manager for OpenShift. That's my day job. I work in identity and access control for OpenShift, bringing open source projects into OpenShift and productizing it and making it enterprise ready. And so SPIFFE SPIRE is one of the projects I've been working on for last 4 or 5 years now. Absolutely love this project and helped bring it on OpenShift for enterprise users. And so I know all the pain points about this and happy to share those with you all. All right. So let's get started. Before I start, I just also want to say that our OpenShift version called Zero Trust Workload Identity Manager is going to be available soon for production environments, and we are excited and bring you insights from that. All right. So as you know, I'm going to breeze through some of these slides just because we have very little time, but happy to continue the conversations after with you and discuss any enterprise use cases that you have. So I always want to start off with this because identity is really the new perimeter in cloud native environments. So as users, you don't want to be identified by where you are, right? You want to be identified by who you are. And the same way we want to respect workloads and be able to identify them as who they are, not where they are. So that's why workload identity matters, and that's why zero trust approach matters. And SPIFFE and SPIRE is a CNCF graduated project. Both are CNCF graduated projects, and they bring zero trust workload identity for enterprise use cases. The SPIFFE is the standard for providing the identity identity issuance framework, and SPIRE is the implementation for it. There have been many talks before this on SPIFFE and SPIRE, so I'm going to try to go over these concepts very, very quickly. Happy to talk about this in more details if you need after. So SPIFFE and SPIRE bring zero trust workload identity issuance and implementation to enterprise use cases, hybrid clouds, different formats, whether you're at edge in the cloud or on-prem, whether you're VMs and containers in different formats for X.509 and JWT. So there are various use cases that they help provide. Today's presentation is going to focus on what does it mean to take this at a production level, right? What are the things you need to consider? So I'm going to be very, very quickly talking about what are the configurations on the control plane side, the server side, the agent or the data plane side, what are the secure configuration options there. I'm going to have to breeze through because of the limited amount of time, but you are free to look at the slides, and if you have questions, I can definitely take those later. We'll also be touching upon some of the capabilities that SPIFFE and SPIRE provide in terms of how to manage scale and performance, how to manage production readiness with the deployment options it has. And finally, I want to wrap up with, no conversation around production happens without scale, performance, HA, and DR. And I get so many questions from enterprise users about this. Great to have this technology. Now, how do I really use it? And how do I really scale it? And how do I really make it work? So I'm hoping to touch upon some of that and provide you with a checklist at the end of this that will give you an idea of, okay, what is it that is needed to make it production ready? It's not an exhaustive checklist, but at least it will get you started. Okay, so why SPIFFE and SPIRE? Again, it's literally black and white. You have to choose SPIRE because it is a standard for workloads that provides MFA for workloads. It provides short-lived cryptographically verifiable identities. It manages the identity issuance, rotation, It provides you with a single schema that you can deploy across your cloud-native deployments. Why that matters is because you can base your governance and policies on that. You can have your automation costs optimized because of having this single issuance framework and enabling workload identity use cases based on zero trust because of that. Okay, very quickly on the SPIFFE SPIRE architecture side, this is important as we talk about the deployment options, etc. SPIRE contains a SPIRE server, which is the control plane or brains of SPIRE. It provides you with registration for your workloads. It is a very rich plugin architecture to enable you to do a lot of production-ready use cases. It provides you with key manager plugins for better data management. It provides you with the Kubernetes plugin. It provides you with different node attestation and workload attestation plugins. And it also provides you with OIDC implementation plugin. So really, it's a very rich plugin ecosystem that is very extensible. And this way, you can manage all workloads, the workloads of today and the AI workloads of tomorrow. The agent side itself is providing the actual workload attestation part. As I said, the server provides you with SVIDs, the issuance, but the agent itself manages the rotation of the certificates, provides you with a workload API that workloads can call to request for identities. So it manages the data plane per node issuance and management of your credentials. All right. So let's look at some very quickly some options on the server side, secure configuration on the server side. The server is your root of trust. So you want to make sure that your root of trust is well defined. It is such that you can control the blast radius of it. So you want to define it such that it's either per cluster or, depending on how your data center is modeled, you can have it defined accordingly. But ideally, you want to scope it down such that you narrow the blast radius here. Some very important things that I want to point out here are use of allow list, for example, and use of audience restrictions. What this does is it only allows certain agents to talk to your server. So you want to make sure you provide that. The Kubernetes PSATs are used for node attestation. This helps you make sure that the audience of the token is restricted only to the SPIRE server. And that's a benefit of using bound service account or scoped service account tokens. Similarly, for VMs, you can use POP, which is proof of possession, and make sure that these best practices are followed. Also, MTLS using short-lived tokens for Bootstrap. On the key management side, you want to make sure that you're using strong cryptographic algorithms. There's a concept called admin IDs that you can use. This, it's a very interesting concept called admin ID, where you can have the server it's like an allow list where registration is not needed. So be careful when you're using the admin IDs, because these can also support federation. So you want to make sure that what you put in the admin ID is very restrictive, because they have a lot of administration access on managing registration on the server side. And of course, you need logging, monitoring, and making sure that you are providing rate limiting for any of the endpoints that you're exposing. In the case of SPIRE, you are providing OIDC endpoints, so you want to make sure you're rate limiting that, for example. All right, and of course, we come to the most interesting part, which is HANDR, right? So I'm going to talk a little bit about that later also, but want to cover here that, you want to consider this is one of the biggest pain points I see enterprise users come to me and say, well, if you have a Spire server, that's your most critical point of failure. So you want to make sure that you have availability for it. You have this behind a load balancer, and you have the right DR mechanisms in terms of how you back up the data store, how often you take backups, and how you provide availability with options such as cloud native Postgres operator, for example. So we are seeing a lot of customers come. Not just for SPIFFE and SPIRE, for a lot of other things also, that they want to make sure that the data stores are correctly backed up and are available in case of disasters and are able to recover and provide availability of, in this case, keys. All right. So quickly around agent configurations. Mostly, I want to skip some of these slides, but what I want you to take away from this is that Spire provides you with a workload API with a CSI driver. So you want to make sure that you harden that access using the right, this is in Kubernetes, it's CSI driver. In the VMland, it's going to be UDS, Unix domain sockets. So you have to make sure the host access is properly configured. You have the right SE Linux AppArmor configurations to secure your the workload API exposure. And you also want to make sure that on the Spire agent side, you have audit logging and metrics and monitoring available to harden the system. Yeah, so this is more on the same side, how to harden the agent itself, how to harden the deployment on the agent, and ensure that, for example, in Kubernetes, FS groups ensures only authorized container access. So yeah, again, the key takeaway here is to have very hardened crypto algorithms used for your key management, to rotate your keys. There are some defaults available, like half the TTL is the recommendation. You can scope it based on your environments and what makes sense for you. But that's the whole premise, is to make sure they are rotated often and they are short-lived. Also, you cannot have a conversation without mentioning post-quantum crypto. So Spire has provided for both the server configuration as well as the agent configuration support for post-quantum crypto. You can enable that settings. Ideally, what you want to do is enable it, test it out with the algorithms that support it today, see how your deployments function, and also have like a hybrid approach. So your CA, if your PKI is supporting a hybrid approach, that's the best thing you want to do, is test it out, enable the settings, see how it impacts your workloads, and then be post-quantum ready. Okay, coming to the most important part, Spire supports two very important concepts, nested Spire as well as federated Spire. So the first thing is nested Spire. When do you want to use it? Nested Spire is great for scaling. And what it does is, Spire provides you with plugins that let you integrate with PKI and integrate with upstream Spire servers also. So your Spire server can be an intermediate Spire server, and you can have a root Spire chained to it. And this is great because this allows for you to scale your, you don't want to have a federation relationship across all your clusters. You might want to have for a single data center. You might want to have your workloads talk to each other very easily. And that can happen if you do if the root of the trust is a single root of trust, and then you have intermediate CAs per cluster. This is also a very great settings. Yeah, I see the time there, but this is also a very great setting for edge deployments, I specifically want to mention that because in edge deployments, you can have the same root of trust as your your central office or your core, and then even when the root is not available, the intermediate CA can still provide certificate signing for your SVIDs. Federation is great when you want to talk to another trust authority. So like if your root of trust is something else, then you would want to go with federation. So one of the best things that SPIRE community has done is provided very, very hardened federation. You are able to federate only in a single direction. This forces you to think about whether you really need to have federation on both the sides. And that way, cross-cloud communication can happen, but you control it. Again, very quickly around SPIRE, HA, and DR, you can take a look at some of these, but ideally you would want geo-redundancy. Nested SPIRE helps with this, this kind of deployment. You want to have persistent storage, and you want to have DR mechanisms such as cloud-native Postgres operator and other ways of using Postgres or any other cloud storage backup. Take care of your storage needs and availability needs. And in terms of high availability for SPIRE, it's a recommendation to have multiple SPIRE servers per trust domain. All right. Here's a lot of things on performance. The upstream has provided great guidance on how to scope your agent, how many agents and how many workloads a single SPIRE server can actually handle in terms of CPU memory usage. All of this information is available. So definitely take a look at that. I've provided some links here. But the recommendation is to you want to have short-lived tokens. If you have long-lived tokens, yes, the load on the system is less, but then it defeats the point. So the best thing to do in those scenarios is to use nested SPIRE to scale your SPIRE deployments, and then make sure that the individual SPIRE servers can handle the load. All right. Very quickly, here's the checklist, for production readiness. Happy to have conversations around this. It talks about, best practices for time to live, key rotation, the admin IDs that I talked about, allow list that I talked about, hardening of the Unix domain sockets and CSI driver configurations. And it also talks about HA and DR capabilities. So hopefully this gets you production ready. Thank you. I can maybe take a question or two, and if not, please feel free to reach out to me anytime. Always excited to talk about SPIFFE and SPIRE. Thanks. Yes, one question.
What about integrating with HSMs, like a cloud HSM? That's a great
Great question, and one of the best practices, in fact. You want to have your especially for the agent side, you want to have your key manager plugins backed up by HSM and hardware root of trust. Disk is another option. If you don't have HSM backup, you can go with storing on the disk. But as you know, storing on the disk is not as secure. And in memory, you don't want to do it unless you're in a confidential computing environment.